Hello everyone, good afternoon. Welcome to the class ECE317 Digital Signal Processing. This lecture is for the, let me see, which week? 9th week, Wednesday's class. And we just had the midterm exam on Monday, right, on the past Monday. So today we will just go over the midterm problems. Okay, here's the problems of the midterm exam. Go to the first problem. Alright, the first problem, it is about, we have three systems and we want to know the type of them. Okay, let me write down. It's a ECE317. This is the 9th week, Wednesday's class. We will go over the midterm problems. Alright. The first one, we have three systems. Okay, we have a table. Table. We have A, B, C, and stable, causal, linear, time invariant. Okay, I just write this. And memoryless, one, two, three, four, five different types. Then we check the first one. First one, t equal to t of x of n equal to x equal to e to the x of n. So of course this is not linear, right? It's an exponential problem. Yeah, we can put it. It is not linear, and it depends on n, right? The output depending on x of n, only x of n. So this is a memoryless as well as causal, right? Causal. If you have some n plus 1, that is non-causal. Like C is not causal, right? C is not causal. And B is also causal. B is also causal, right? B is also causal. In both A and B, we have x of n, x of n minus 1, x of n minus 2, right? No x n plus 1. Go back A again. And stable. Whether it is stable for A, I put it here. A for the stable or not. That means if x of n is bounded, right? This means x of n is bounded by a bound B. Then we can have the output is e to the x of n, or bounded by e to the absolute value of B, right? Just B, yeah, e to the B. So this is a bound, new bound. This is a bound for the output, right? It's also bounded, so BIVO. Bounded input give you bounded output. If input is bounded, the output is also bounded. The bound is different, but it is bounded. Okay, so this is stable. This is stable. And time invariant, if we shift x, then output is also shifted, right? This is also time invariant. Time invariant. Then for B is okay. B is what? So far we already learned a lot about the LTI system, right? So B is a typical LTI system, right? So we can just know this is a LTI system. And for memoryless, it is not, because we have x of n minus 1 and n minus 2, right? So we need to remember something. If you only have x of n, that is memoryless. Now we have some others, so it's not memoryless. And the stability, this is also stability, also stable, right? B is also B for the stable. We can also have this one if x of n is bounded by some B. Then the output 0.6 x of n minus x of n minus 1 plus 1.3 x of n minus 2. This one, we take absolute value. It was smaller than or maybe equal to 0.6. If here is equal. Okay, no equal, just smaller than 6.6 times this one. This one no more than b, right? Smaller than b. And this is minus, or maybe this is negative value. The absolute value is smaller than b, right? So you just put plus b. This is number over this one, right? This is a bound. B is a bound, right? B must be a bound of this term. And last term similar, it will be 1.3b. So totally is 2b, right? Oh, not 2, sorry. 0.3, 1 is 1.6. No, 0.6 and 1 is 1.6. 1.6 and 1.3 is 2.9. 2.9b. Anyway, this is a bound, right? This is a bound. So this is also BIBO. So this is also stable. B is also stable. And similar, C is also stable. Right? C is also stable. C is also stable. And then for C, we have 3 other cases we didn't check. Whether it is linear, we say no, because we have 1. Right? For C, 1 equal to 1 times x to the 0th power. Right? Power is 0. So this is not linear. Linear, you have to use all the linear term. The power should be 1. Power should be 1. Must be 1. This is power 0. So it is not linear. Not linear. And time invariant? Yes, this is time invariant. Right? When you shift the x, the output also shifted. Yeah, you both sides you replace x by some x minus and d, you will get both sides are equal, right? So this is time invariant. And the memoryless, no, it is you have n minus 1, also you have n plus 1. Now both need memory. Okay, so this is for first problem. I will give the point. Each result is 1 point, totally 15 result, right? 15 point. And this part is not necessary. You write some notes here to explain how can you get this result, get your decision. That will be fine. If you do not have them, it's also fine. You just check here, is also fine. All right, I just give grade according to your result. Okay, so this is the first problem. And second problem. Okay, second problem. We have x of n. We want to find the Fourier transform. We want to find the Z transform. Z transform and is RC. So we need 2 things. We have at least we have 2 ways to solve it. Okay. We want to solve it. This one, you see, when n negative, xn must be 0, right? Both are zeros. When n is larger than 8, larger than or equal to 8, the xn is also 0, because u of n equal to u of n minus 8 equal to 1. Right? If n is larger than 8, then u of 8, larger than 8, this is 0, and the minus 8 is larger than 0, so this is also 1. So both are 1. This is 1. This is 1. Subtract is 0. Sorry. Yeah. Yeah. If both are 1. Yeah. Yeah. This one minus this one is 0. Each. Both of them they are 1. Okay. Then only when n between 0 and 8, not include 8, we have x of n equal to 1/2 to the n. Right? This is the second. This is second. So we can list like this is n0 is 1, then 1/2, 1/4, until 1/2 to the a. 2 to the n is 7, right? 2 to the 7th, 2 to the 7th, like this. This is this one. Okay, then you can have x of z just by definition. This is a 1 times z to the 0, and 1/2 z to negative 1, and 1/4 z to negative 2. Then 1 over 2 to the 7th z to negative 7. The result is this one. This one. In our C, z cannot be 0. That's it. Right? You can use any z other than 0. And if you want, you can do some simplify. This is a denominator, numerator is 1 minus 1/2 z to negative 1 to the 8th, and numerator, this is numerator, denominator will be 1 minus 1/2 z to negative 1. You can have this. You can have this. This is RC. This is a z transform. This is z transform. V2. You can just use tables. You write this as 1/2 to the n u of n minus 1/2 to the n u of n minus 8. Then this one we can find it directly from table. And this one is shifted by 8, right? However, you see these two n are different. This n is shifted by 8. This n just n itself. We want they are same. So I can write in this way. Half to the n u of n minus, I move 8 in the front. And then here's a n minus 8. And the u of n minus 8. Okay, so this part, the both ends contain the followed by a minus 8, right? So this is shifted by 8. The whole thing is shifted by 8. Then we can have the result. The first one, it is 1 over 1 minus 1/2 z to negative 1 from table directly. And the second one is 1 minus 1 over 8 to the 8. No, I'm sorry. Here's 8. 8. Yeah. 1 over 8 to the 8. 1 over 2 to the 8. I confused it here. Alright. Yeah, I say 1 over 2 to the 8th. But, I speak faster than my hand. When I write, I try to write this 2, I'm speaking 8, so I put 8 here. It should be 2. 1 over 2 to the 8th. Yeah, 1 over 2 to the 8th. This is 1 over 2 to the 8th. And then this part, it is shifted off this one. Okay. This one shifted by 8. So it is 1 over 1 minus 1/2 z to negative 1 and shifted by 8. Alright, so this one. And RC, yeah, we checked from the table. This one, RC is z larger than 1/2. And this one is also z larger than 1/2. So we can have RC, this one. Okay, you compare these two results. Actually, this part is the same, right? Denominator is 1 minus 1/2 z to negative 1. And the numerator is 1 minus 1/2 and z to the negative 1 to the 8th. So this, you see, actually these two are same. These two are same. You combine these two fractions together, you get the first result. They are same. They are x of z are same. X of z are same. But RC are different. RC are different. You see, this RC is z not equal to 0. This RC is z larger than 1/2. What is the problem? Which one is correct? You can say both are good. Both are good. Why? This one, RC, is a part of that. Part of that. Okay. So this one larger, contain this one. Contain this one. So this one is also inside the RC. Inside RC. So you can say this is a part of the RC. You can say this is a part of the RC. Why you have this? Because you use a table. Use a table so that works everywhere, but sometimes it's not so accurate. You will have something not so accurate. So this is things what happened here. If you do it, use the definition, you'll have the first answer. This is totally correct answer. This is 100% good. And this one we can see like 90% good. However, if you use both method, either method, you'll have full credit. Okay, I won't drop credit if you use this one. Even you have a smaller RC, you're still good. You're still good. All right. Okay. This is the second problem. Okay, problem 3. We have edge and we have a signal. Then input signal, we want to find the following things. First one is A. What is the frequency omega 0 of x of n? Now you look at, you have cosine. X of n is here. Use cosine of something. Cosine of something, we have two numbers, 2/3 pi times n. And here is a plus 1/3 pi. So actually 1/3 pi is a phase angle, right? The first one, 2/3 pi is the frequency. So we have omega 0 is 2/3 pi. Is it A? Now B, we want to find the value of the frequency response h of e to the j omega at omega equal to omega 0. Alright, this is just a, you plug in, you can have the result. It's a fraction. Now it is e to the negative j omega 0. Omega 0 is 2/3 pi. Minus e to the negative j 2 omega. 2 omega will be 4/3 pi. And here's 3 minus e to the negative j 3 times, okay, this is 2 pi. Alright, the denominator is fine. Then we can do some simplify. The denominator is just 3 minus this one. We use a Euler formula, right? We have to use Euler formula. E to the j a or equal to cosine of a plus j sine of a. Right? We always have these. Now we apply this one. This e to the negative j 2 pi, there will be cosine of negative 2 pi plus j sine of negative 2 pi. This is the denominator. Actually, you should know this is 0, this is 1, right? Then numerator, we have more space. We have two exponential power, so we need 2 of them. So first one is, actually here you can write in this way, then you can write, let me write it. It is a cosine of negative 2/3 pi plus j sine of negative 2/3 pi. And minus cosine of negative 4/3 pi plus j sine of negative 4/3 pi. So the denominator is 3 minus, this is just 1, right? Minus 1, and this is 0. Sine of negative 2 pi is 0, so it's just 3 minus 1. And the denominator, they are the special angles, right? 2/3 of the pi is, no, 1/3 is 60 degrees, right? 1/3 is 60 degrees, so this is 100 degrees. And 2 of 100 is 240 degrees, 120 degrees. This is 240 degrees. If you can remember the sine, cosine of special angles, you can write it here. But if you can't, you can use a calculator or MATLAB to do it. Right? Yeah, I can just use MATLAB to see what are these. For MATLAB, Well, I can just use the exponential power, right? Exponential power of negative. Can't remember. This one, right? It's here. It's here. So it is exponential power negative j times 2 over 3 times pi. Right, this is the first term. What it is? Okay, it's negative half. I just copied. Negative half minus point. Actually, this is square root 3 over 2j. It's I. We use j. This one, I just copied it from my left. Alright. You see both? Yeah. This one, right? Okay. And another one is cosine of, here's a 4. 4 over 3 pi, right? 4 over 3 pi. It is another negative half plus square root of 3 over 2j. Yeah, did this one. Did this one. Okay, then we can do more simplified. Denominator, it is just 2. And the numerator, we have negative 1/2 minus negative 1/2, I get 0. And this is a negative, this j minus this j. Okay, what it is? This is a 2 of this, right? 2 of this. So this is negative square root of 3 over 2j. So this is a h of e to the j omega. H of e to the j omega. Well, omega is omega 0. Right. Then we keep looking at the problem. We have b, then c. C, what is the magnitude? Magnitude is what? It is this one. Magnitude, you take the absolute value. It's just the square root 3 over 2, right? That's 0.866. Right, it is just this one. And then the angle. What is the angle of this? You give a graph, you can see the point will be here, right? Some negative value times j, so it's here. Yeah, it is here, right? This one. So the angle is what? Is negative pi over 2. Okay? This is the angle. Negative pi over 2. You can also use MATLAB to get it. Use MATLAB to get it. It's an angle of that is a 0.866 j. Right, it's this one. What is the angle of this? Oh, I have negative in front of it. Negative 0.866 times j. This is negative. Yeah, it is pi over 2, right? Negative pi over 2. Negative pi over 2. Same number, right? This is the phase angle. This is a negative pi over 2. The same number. The same number. This is negative pi over 2. Alright. Okay, so this is part C. Then we go to the problem, last part. D, find the output of the signal y of n. Output signal, right? Output signal. Now we can just write it down. Output signal y of n will be, because input is a cosine, output still be cosine, but the phase, the amplitude and phase, both amplitude and phase will change. The amplitude change to be this one, so 0.866. Original one is amplitude is 1, right? X of n is just cosine, so amplitude is 1. Now the amplitude were replaced by the magnitude of h. Then cosine, frequency is the same, 2/3 pi times n. And phase angle, original we have a 1/3 pi. Now we add one more. This is a negative pi over 2. Okay, that's it. This is the final answer. If you want, you can do simplify. Let me write here. Okay, A66 cosine of 2/3 pi n. These two, I add them together, will be what? Plus 1/3 and minus. This is a 0.333. This is 0.5 negative. So will be 0.1663. This one is minus 1/6. So this one. The final answer is this one. You leave this is also fine. All right. You leave this part is also fine. Give the simplify. You get this one is also good. All right. Okay. So this is problem 3. Problem 3. Okay. All right. Next. Problem 4. Problem 4. We have a system with equation. We have ABC 3 questions. Okay, we go step by step. For A, determine all the possible homogeneous response of the system. So this is just you let x equal to 0. So homogeneous equation. Y of n minus 1.5, y of n minus 1 plus 0.5, y of n minus 2 equal to 0. Then you need to consider, well, you have several ways to write the equation here. I use the most longer one. You can have shorter way actually. Just let y equal to lambda to the n. Then this is lambda to the n. This is 1.5 times lambda to the n minus 1, and this is 0.5 times lambda to the n minus 2. Right. We have this equal to 0. Then I times lambda to the n minus 2 on both sides. Right. This is equation. The both sides we times the same thing, you get the same thing, right? These two you times them, you get not times, divided. So this one divided by this, you get lambda square. And this minus 1.5 times this one divided by this, you get lambda. And this one divided this, you get nothing. So this is 0.5 equal to 0. Then we have lambda minus 1 times lambda minus 0.5 equal to 0. You can also try lambda equal to 2. Here's 1.5 plus or minus square root 1b squared minus 4 times 0.5. Then you do a calculation, you can have these two numbers. So we have lambda equal to 1 or 0.5. Then we have the homogeneous solution, which will be alpha 1 times 1 to the n and alpha 2 times 0.5 to the n for any alpha 1, alpha 2. You can choose any value for alpha 1 and alpha 2. If you want to write more, this is a simplified. This is just alpha 1 and alpha 2 times 0.5 to the n. Okay, so this is the part A. And part B. Use Z transform to find the particular solution where, okay, x input is given. Okay. Input is given is 1/3 to the n times u of n. And you need to indicate what is the related RC. Okay, here we can have this, right? We check the original signal. We know y of z, that will be 1 minus 1/3 z to negative 1 over 1 minus 1.5 z to negative 1 plus the 5 z to negative 2 times x of z. We have these. And x of z now is 1 over 1 minus 1/3 z to negative 1. And our c here is z is larger than 1/3. Right? This is the x of z because x of n is 1/3 is given like this, right? So you from this x of n you can have its z transform will be this with this as our c. Sorry. You got it? Yeah. Yeah, this is a x of z, this one with this RC. But this part we do not know what is RC. That means you can choose any one for its RC. Okay, let me do a simplify. This 1/3 and 1/3 you cancel. So it is 1 over, and this part we can write as 1 minus z to negative 1 and 1 minus 0.5 z to negative 1. Okay, now how to choose the RC? Here you have z larger than 1/3, but here you see this is 0.5, this is 1. You do not have 1/3. Actually, they cancel. So you can choose RC just based on these two poles. We have three possible choice, right? 0.5 and 1. You can choose the RC is outside this circle or inside the circle or just in the ring. So you have three choice. You can choose either one. And here I just suppose like I use RC equal to z larger than 1. Larger than 1. You just use the larger one. Use the larger one. Then we do the inverse transform. Find the inverse. By the inverse z transform. We have y of z equal to a over 1 minus z to negative 1 plus b over 1 minus 0.5 z to negative 1. And then y is this one, now equal to this one. So that means 1 will equal to a times 1 minus 0.5 z to negative 1 plus b times 1 minus z to negative 1. Right? Make sense? Numerator should be 1. Now these two, you add these two together, the numerator will be a times this plus b times this. So it should be same. Now you can also consider these two are same. Then you multiply this denominator on the both. Then this one you times the denominator, you only have 1, right? The denominator cancels, this is 1. And this one you times this denominator, so it's, this one cancels, you have a times 1 minus 0.5 z to negative 1 and b times 1 minus z to negative 1. Alright, now we let z equal to 1. This is 0. So we have 1 equal to a times 1 minus 0.5 over 1. Right? Z to negative 1 is divided by z. Z is 1. So this is what? This is 0.5 times a. Right? So we have a equal to 2. And let z equal to 0.5. Then we have a equal 1 equal to a 1 minus 0.5 over 0.5 plus b 1 minus 1 z to negative 1 is this one, right? Z is 0.5. Okay, so this one is 1 equal to, this is 0, and the b times, now is 1 minus 2. Right? 1 minus 2, so it's a negative 1. So we have b is negative 1. Okay, now we have the y particular of n, you just do the, if you do the inverse from here and you choose RC is larger than 1, then we have, this is a B, this is A is 2, times this one in time domain will be just U of n. And the B is -1, and in the time domain this will be 0.5 to the n U of n. Okay, so we have the particular solution. We have the particular solution. Now let's see. Yeah. So we have, this is the answer with RC, this one. If you choose different RC, also good. Here I choose this one. If you choose different RC, and this place might be different. If you have some z smaller than some number in your RC, then this part you need to have u of -n minus 1, right? Remember? Yeah, we have that term in the table. Okay, this is y particular. We have finished part of B. Now is C. C, we want to find okay, with the same input, now we want to determine output if we have initial condition. Okay, we have initial condition. Yeah, we have initial condition y equal to 1 when time is -1 and 0. Okay, now we know yr, it is just y particular solution plus y homogeneous solution, and we know y particular solution when n is -1 plus homogeneous solution when n is -1. This is what we want. This is the first initial condition, the y of -1 equal to 1, right? And y particular solution of 0 plus y homogeneous solution of 0, this will be also 1. This is another initial condition. Okay, now we just plug in. We can have y particular solution is here. When n is 0, when n is negative, this is 0, this is 0. So what y particular is just 0. And minus homogeneous solution with n is -1. We have homogeneous solutions here, and n is -1. So it is alpha 1 alpha 1 plus alpha 2 times here's n is -1. So it's alpha 1 plus alpha 2 times 0.5 to the -1. Okay, this is 1. Then look at second. Now n is 0. N is 0 for particular solution. Here, particular solution, n is 0, you get 2, right? N is 0, this is 2. And this is n is 0, you get 1. You get 1, right? Minus 1, 2 minus 1. This is 2, this is 1. This is 2. No. This is 2, this is 1. This 2, this 1. Or n is 0. And then for homogeneous solution still here, but n is 0. N is 0, so this alpha 1 plus alpha 2, right? This is 0. 0.5 to 0 is 1. So just alpha 1 plus alpha 2. This will be 1. Alright, almost done. We have these two equations, then we try to solve it. We can have the final answer. So the first one is alpha 1. This is a divide by half, that is 2. Plus 2 alpha 2 equal to 1. And here's alpha 1 plus alpha 2 equal to, this is a 2 minus 1, you get 1. 1 plus something still equal to 1. So this part have to be 0. Right? This part has to be 0. Alright. Then, okay, this one is simple. I just subtract these two. The first one subtract second. Alpha 1 minus alpha 1, you get nothing. alpha 2 times 2 minus alpha 2, I get alpha 2. And 1 minus 0 is 1. You get alpha 2. And then you can use either one. Alpha 1 plus alpha 2 is 0. So alpha 1 must be negative 1. You can also use the first. Alpha 1 will be 1 minus 2 of alpha 2. Still negative 1. Okay. Then we can have our answer. Y of n will be a particular solution plus homogeneous solution. Okay, let me put the homogeneous solution first. Alright. Homogeneous solution will be alpha 1 plus alpha 2 times 0.5 to the n. Okay, alpha 1 plus alpha 2 times 0.5 to the n. Okay, alpha 2 is 1. And then particular solution is this. So plus 2 of un minus 0.5 to the n u of n. So the final answer will be this. Okay, we are done. But of course, here I use the particular solution is this one. I obtain this one based on the RC is this. Based on RC is this one. If you choose different RC, you will have different particular solution. And then finally you will have y of n in a different form. The formula might be different. Formula might be different, but actually they are same. If you plug in different n, the values of n inside it, no matter which way you get y of n, you will see all of them they are same. Okay, this is problem 4. Alright, that's all for these problems, and if you have any question you can ask me during the office hour, or you put your question in the piazza, or you email to me. And then that's all for today. See you next time. See you on Friday. Bye bye.